Good morning, students. Hello, can you hear me? Hello, hello. Am I audible?
Yes, sir.
Yes, sir.
Okay. So only this much students or students has not joined still now. How many students are there? Hello.
Sir, seven.
No, no. This is inside the class and in total class, whether any classes has been done already for this semester.
Uh, I am. I do not know about this, sir. Totally student.
Okay, only this much has joined. Seven, not seven actually. Myself is there and one is for that recording. So only five students are there. Okay, they're joining, but if it's possible to join, I will just announce this thing in the class. At least you should try to join before 10 minutes. We shall start at dot 10 or like that. We should not waste any time.
Sir, many students join very late
No, no, this
generally.
can't be done from next day because
So,
after
okay,
five
sir, you
minutes I will
start, let them join afterwards.
because the my screen will not be there in front of me. Na, in that cases it will become problematic. They will
Yes,
waiting.
sir, of course.
So from the next class onwards, I will permit maximum up to 5 minutes. After that, no one will be able to join. I will just announce this thing because we should not waste any time. We have only five classes for this algorithm subject, and it's one huge subject. So we should not waste any time in that case. So we shall start it. Let's wait for two minutes more, and then I will close the classroom. Let's start it. Is the copy visible to you?
Yes, sir.
Okay. Now, before start with algorithm, let's start with a very small program. Suppose int x is equal to 0, printf percentage d x. This is one thing. Another thing, int x is equal to 0 for I is equal to 0, I less than 10,000, I plus plus, Inside that, I'm using another 4. J is equal to 0. J less than 10,000. J plus plus. I am using x is equal to 0 and I am using printf percentage d x. What will be the output of these two code? What will be the output of these two code? Just a second. What will be the output? Anyone?
Sir, can I see the first code?
Yes, I'm
Sir,
showing.
it's not okay, sir. So first code will be zero, only zero, and second code will be also 10,000 times 10,000 zero.
So output will be same, isn't it?
Yes,
In
sir.
both the cases, the output will be 0. But what is the difference between these two?
Number of times means
So
here
that
we are
means
using
what?
a loop, two loops. Here we are not using loops in the first case.
So that means unnecessarily I am wasting time. Output is same, isn't it?
Yes, sir. Yes, sir.
So that means somehow this kind of construct has to be avoided to reduce the execution time. This is the basic essence of algorithm actually. Algorithm, this is that algorithm is what? Actually, representation of program in our language, in human understandable form, isn't it? We are just write down the steps of the program. But here, every time the efficiency of the algorithm will depends on that time requirement of the program and space requirement. Based on that, this is called actually the complexity. Two types of complexities are there. One is space complexity, another is time complexity. Already in data structure, you have done that one, that big O notation. Okay, big O. You have done that one in sorting or in searching in data structure. Can you remember? It has not done in data structure. At least whether yes or no, something has to be there no answer, whether you have done it or not. This is number of elements or number of loops executed. Number of times the loop has been executed. This is n, suppose. Number of elements. And this is time required to execute that in number of variables or in number of statements. This is. Now here, one function can define this. This is called, suppose my function is f of n. The time requirement for f of n is like that. If the n increases in that way, time first increases, then that should be decreased. And here, this is another thing. What is this one? We will come to that point. G of n. Actually, here, this is also known as London notation. London notation, or this is big O notation actually, or Bachmann-London notation. It describes limiting behavior of a function in terms of simple functions. That means here how this can be defined: a function f of n. F of n function means it can be anything. Suppose f of n is equal to n square plus 2n plus 3, in that way, some linear equation. So this is the function. Function f of n is said to be in big O of g of n, is said to be in big O of g of n. That means what? big of g of n is total all solutions for function, and g of n is one specific solution. G of n is one specific solution. If f of n is bounded above by some constant multiple of g of n for all large, that is, if these exist some positive constant c. That means what? To be very simple, f of n is the function any specific solution. Obviously this should be less than is equal to all solutions. Sorry, f of n belongs to, sorry, f of n belongs to big O of g of n. That means f of n is one solution in a specific moment, and g of big O of gn contains all the solutions. So any one solution will be there inside g of n. So that means f of n belongs to big O of g of n. Is that clear or not? Any one solution, obviously this will be there inside the all solutions. Is that clear or not?
Yes, sir.
Now this can be written as f of n, then this can be written in mathematically less than is equal to c of g of n. C is that constant, whatever we are saying. So that means there exists some positive constant c. So here this is the definition for big O, that one solution always will be less than is equal to all solutions, and this is the positive constant c. One positive constant c will be there such that n means this one, all solutions, all numbers will be greater than is equal to some specific number in some moment. So this is the definition of big O. This will be there in the exam. So that means f of n is one function which is present under all solutions. Any specific moment solution is f of n. All solutions are big O of g of n. That means f of n belongs to big O of g of n for any equation, this kind of linear equation. And where very carefully note that this is less than is equal to big O of g of n. That means one solution will less than is equal to c of g of n. If we are coming to one example, this will be more clearer. Just a minute, I am coming to example. Suppose I have one solution. This is from one university question, your university question. So my question is for the function defined by, if any question is there, you will ask me, no hesitation. 2x cube plus 3x square plus 1. This is my equation. I have to prove, this is the university question, so that f of x is equal to big O of x cube. We have to prove that. We have to prove f of x is equal to big O of x to the power 4. We have to prove x cube is equal to big O of f of x. This kind of questions will be there. We have to, these are very simple thing. I will analyze this thing. X to the power 4 not is equal to big O of f of x, and from that f of x not is equal to big O of x square. These things has to be proved. Note it down, the question. Note the question. And one more thing, whether you have any WhatsApp group. Did you
Yes,
have
sir.
any WhatsApp group? So how many students are there? So I am providing you my number. Just add this one over there. I will put some notes over there.
So please tell the number. 94022
94322549112. Add this one. Now, just go for the solution. We will now consider for the first one. We have to prove that f of x is equal to big O of x cube. Now we are taking the first condition. F of x is equal to 2x cube plus 3x square plus 1. This has been given. Acha, now can it be written, tell me, less than is equal to 2x cube plus 3x cube plus, acha, 3x square plus x square for all x greater than is equal to 1. Can it be written, is it true or not? F of x is what? 2x cube plus 3x square plus 1. Put 1 over here. What is the value? 2 plus 3 plus 1 is equal to 6. Here 2, 2x cube, sorry, 2 plus 3 plus
1.
1. So this is less than is equal to, this is also 6. Now put x is equal to 2. What will be the value? X is equal to 2. 2 into 8 plus 3 into 4 plus 1 is equal to 16 plus 12 plus 1. What will be the value? 29. What will be the value over here if we put 2? 8 plus 12, sorry, 16 plus 12 plus 4. This is true. This is greater than is equal to 29. Is it true or not?
Yes, sir.
Yes, sir.
So for all values of x greater than is equal to 1, it will be true. Similarly, we can write this will be less than is equal to 2x cube plus 4x square. That means I am just adding. That will be less than is equal to 2x cube plus x cube. Can it be written or not? Again put the value. If it is 2, that will be 29. If it is 2, that will be 16. 16 plus what?
8.
Sorry. Can it be written or not? Obviously, this would be larger. This is 48 itself. Isn't it?
Yes, sir.
So that means less than is equal to 6x cube. 6x cube. That means just now here c becomes 6. Compare it. F of n less than is equal to c of g of n. That means here f of x less than is equal to c means 6 g of x cube. Can I write down this thing using that one? The same thing over here. Okay. So complexity is big O of x cube. Is that proved or not? Any question? Is it clear or not? Any question?
Sir, can you tell once more where we are getting excess cube from x square on the 2x cube plus 1?
No, this is the assumption. If we put
Okay.
that one, whether my condition will be true or not.
Okay, sir.
If we put that one, whether my condition, this is by induction. I am implementing this one, and I am proving that this will not distort my condition. My condition will be same. Is it true or not?
Yes, sir.
In place of 1, I just put x square. In place of x square, I just put x cube, but my equation has not been changed. My condition has not been changed. It will be always greater than f of x. So my condition will become f of x less than is equal to c of g of n. So if this is true, f of n less than is equal to c of g of n, that means what? This is big O. So this will be big O of x cube. Complexity, that means the complexity or time will be dependent on x cube for this equation. Is that clear? Any question? Don't have to hesitate. Any question? What's the problem? Because first the complexity has to be clear in every respect. Then only we will be able to discuss all the other things in algorithm. What's the problem over here?
Sir, will we have to show that by using 1 or 2 means putting the value of x greater than 1 and doing
Yes,
one of the
it can.
solution? Okay.
Yes. It can be done, and that will be better. I am showing you. I am
Okay,
just
sir.
showing you for the next problem. What was the next question? We have to prove f of x is equal to big O x to the power 4. Okay. So now, actually, the method of induction is like, say f of x. For my next question is f of x less than is equal to 6x to the power 4 for all x greater than is equal to 1. How? F of 1 is equal to 2 plus 3 plus 1 is equal to 6. Am I clear?
Sir,
Tell me.
so why it is 6x to the power 4?
Why? Like previous one, if it is 6x cube, it may become 6x to x to the power 4, isn't it?
Yes, sir.
Similar way, I will put x to the power 4, I will put x to the power 4, I will put x to the power 4 over here. But my condition should be same. It has to be greater than that one. It has to be greater than 2x cube plus 3x square plus 1, greater than is equal to. That condition is true or not?
Yes, sir.
So that condition has to be true every time. Otherwise, you can't told that, because my big O notation is f of n less than is equal to c of g of n. Always this should be less than. So on the similar way, I am writing over here and put the values. F of 1 is equal to 6 and 6x to the power 4 means 6 less than is equal to true or not? Less than is equal to true or not?
Yes, sir.
I put x is equal to 2. F of 2 is equal to what? 2 into 2 cube plus 3 into 2 square plus 1 is equal to 29. Here 6 into 2 to the power 4 is equal to 6 into 16. Is that true or not? Less than is equal to?
Yes, sir.
So f is equal to 3. 2 into 3 cube plus 3 into 3 square plus 1 is equal to 82. 6 into 3 to the power 4. Obviously this should be less than. So for c is equal to 2, I put that, suppose f of x, c is equal to 6, f of x less than is equal to 6, when c of g of x to the power 4. তার মানে complexity, that means complexity will be big of x to the power 4. Proved or not? Where is the problem?
Sir,
Hmm.
for every natural number it is true.
You have to provide the condition. This one. It's not true for 0. Just see that it's not true for 0.
Yes, sir. But for every natural number it is true if we provide this
Yes,
condition.
yes. So this condition has to be provided. You have to provide for which condition? Obviously. Otherwise, this will not be true directly. We can't hold that one. So one thing you should remember, actually the thing is that we are proving this thing, but actually the thing is that the highest power will be the complexity. This is the simple thing, but we have to prove in that way. Always highest power will contain the complexity. Sorry, complexity contain the highest power. It's clear now. We are coming to another example. No issues. We are coming to another
So
example.
please, sir, please show the next page once. Okay, sir.
My question is, I have to calculate again the university question. Find the big O notation for the following function. One is f of n is equal to 5n cube plus n square plus 6n plus 2. By viewing that equation, I can easily say that the complexity will be n cube, but I have to prove that one. How? Say f of n is equal to 5n cube plus n square plus 6n plus 2 for n greater than is equal to 2. Here n greater than is equal to 1 will not satisfy. You can check that one.
Yes, sir.
So 5 n cube plus n square plus 6n plus 2, it will be less than is equal to 5n cube plus n square plus 6n plus n. That means that will be less than is equal to 5n cube plus n square plus 7n. If any problem is there, you will just ask me. Now for n square greater than is equal to 7n, if we put 5n cube plus n square plus 7n less than is equal to 5n cube plus n square plus n square. Can it be written or not? Tell me. 5n cube plus 2n square. N square greater than 7n means what? Actually, n greater than 7. If we put that one, whether this will be true or not. Any question? Similarly, we are putting for n cube greater than is equal to 2n square. That means actually we are putting n greater than is equal to 2. 5n cube plus 2n square plus 7n, that will be less than is equal to 6n cube. So f of n is equal to big O of n cube. Any question? Any question from here? Any question?
No,
Or it's not understandable? Acha, what is it? Samantha, Samanta? Some uncommon name.
হ্যাঁ স্যার সমতা সমতা দাস
Oh, আচ্ছা আচ্ছা ঠিক আছে I think that this is not Bengali name first time তো ঠিক আছে চলো so any problem please share any if any problem is there we shall discuss because if these steps are not clear nothing will be clear in algorithm any question so that's clear
yes, sir.
now this is big O deals with less than is equal to condition less than is equal to condition because here we are considering now come to this one we are considering now actually big O portion will be the solution portion or solution portion will be that one the intersection of these two g of n is one specific moment and this is the nature of function f of n if n increases the function or the time took by the equation will reduces in that way and this will be one specific moment will be increased in that way and intersection will be the solution area that means this one x greater than 5 x greater than 7 only this area will get the solution so here that means you can easily say this is my any specific moment and this is the upper bound of the equation so this is the upper bound of the equation and big O notation actually represents the upper bound of the equation. Similarly, we will have another notation. This will represent the lower bound. This is the big omega. So exactly the thing will be reverse. We are coming to that point. The total thing will be reverse over here. How?
Sir,
Yes.
big O only deals with less than equal to condition.
Yes, this is the upper bound for that. And here, in case of big omega, it will be clear. I am coming to that point. It will be very much clear. Say, in case of big omega, just the reverse thing will be there. This is the function and this will be your g of n. So this will contain that function of n contain the lower bound. So here the condition will be f of n greater than is equal to c of g of n. I have to prove that one. And if this condition is proved, that means we can say that complexity is big omega. Big omega. This is the big omega. Big omega notation. So I'm coming to one example. It will be very much clear. Suppose my equation is f of n is equal to 5n cube plus n square plus 3n plus 2. If we have that equation, can it be written? Just tell me. 5n cube less than is equal to 5n cube plus 3n square plus 3n plus 2. Whether this is true or not for all values of n. any values of n, because this constant term is there, obviously this would be lesser. Is that true or not?
Yes, sir.
This part is f of n. So can it be written f of n is greater than is equal to 5n cube? Is it true or not? Is it true or not?
Yes, sir.
So is that similar to that? For all values of n. So f of n is equal to big omega of n cube. This is proved. Any problem, any question from here? Suppose another university exam question. F of n is equal to 3n cube, sorry, 3 to the power n plus 6n square plus 3n. Now here 3 to the power n less than is equal to 3 to the power n plus 6n square plus 3n for all values of n. Whether it is true or not, tell me just. Show f of n greater than is equal to 3 to the power n. Is it true or not? Can it be written? Just tell me where is the problem, if any problems are there. Try to understand very carefully. And one more thing, try to join before 10 minutes. I will open the classroom from next class onwards. Still now some are waiting. It's not possible to allow students throughout the class. I will not allow. Maximum 5 minutes. After that, no one will be allowed inside the classroom. I will open the classroom at least 10 minutes before starting of the class. Any problem, Pritam?
No, sir.
So what about the others? Motuli,
No, sir.
Partho?
No, sir, I understood.
Okay. So this is big omega. I will provide you lots of questions. Just add me on that WhatsApp group. I will put some notes. And I will be there in the group till our session ends. Means 5 sessions are there, 5 classes are there. Then I will exit from the group. No issues. Okay, now the next one, the third one, which will deals one. This is big O. This is deals with the upper bound, big omega. This is deals with the lower bound, and sorry, big. And another one is that big theta, which deals with the in between range between the upper bound and the lower bound. So here, big theta will be like In that way, number of elements n or number of comparisons, whatever n. And here T of n, this is T of n. Here f of n is, this is C2 of g of n. Another one,
Sir, what is the meaning of these curves?
this is the plot. If we are increasing the n in that equation, the time requirement should be like that. In any specific moment, number of n's are that one and time requirement is that one. This is experimented.
In all three, big omega, big O, big theta.
Exactly, all are experimented. You can put the values in that way for any equation. That will, the nature of the curve will be like that.
Okay, sir.
Now here, this is our function in between that, f of n. You can easily see that in case of big theta, this is the lower bound. Already we have proved that one. C1 of g of n. And this is the upper bound, C2 of g of n. And in between the lower bound and upper bound, the nature of the curve function of n. In between the lower bound and upper bound. So this is the big theta. So we have to prove in case of big theta that value of the equation actually every time lies in between upper bound and lower bound. We have to prove that one. How this can be proved? Say our example is find theta notation for the given exponential function f of n 3 into 2 to the power n plus 4n square plus 5n plus 2. This has to be proved. So for finding theta notation, first we find lower bound for f of n. First we will go for the lower bound. So to calculate lower bound, already we have done it. Already we have done the lower bound. How? 3 into 2 to the power n less than is equal to 3 into 2 to the power n plus 4n square plus 5n plus 2. Can it be written or not? For all values of n. Can it be written or not?
3x. Sir, 3x into 2 to the power n.
3 into
Okay. 3
into 2 to the power n.
less than. Yes, sir, it's less than.
This can be easily written
Yes,
because
sir,
this plus 2 value is there and lots of other values are there.
yes, sir.
So that means here C1 is equal to 3, suppose g of n is equal to 2 to the power n. Then we can easily write down f of n is equal to big omega of 2 to the power n. Can it be written or not? Just now we have proved that one. For lower bound. For finding theta notations and that, we will find we find the upper bound. How the upper bound will be calculated? 3 into 2 to the power n plus 4n
Excuse me, sir.
square. Yes,
Sir, what is the meaning of lower bound and upper bound?
this one is big O.
Okay.
This is g of n. The curve is for any specific value, and f of n contain all values. So here this is the bound which is lies above the specific curve. So this is the upper bound.
Okay. G of x.
G of n. Yes.
Mhm.
And this is big O. Big omega is that one. Here g of n contain this curve and function all solutions are that one. So this is lies below the curve. So this is the lower bound, big omega.
Okay.
And big theta between these two, upper bound and lower bound. In between that the curve goes over here.
Okay, sir.
So now this one, for finding that upper bound, we are taking 3 into 2 to the power n plus 4n square plus 5n plus 2. That will be less than is equal to 3n cube plus 4n square plus 5n plus n. It will be true or not? For which value you have to provide? Obviously, inside the bracket, n greater than is equal to 2. Put the value and tell me whether this is true or not, if any confusion. Is equal to less than is equal to, that means 3n cube. 3n cube ছিল না তো, 2 to the power n, sorry. 2 to the power n. Yes.
Yes, sir.
3 2 to the power n, sorry, 3 2 to the power n plus 4n square plus 6n. That will be less than is equal to 3 into 3 into 2 to the power n plus 4n square plus n square. N greater than is equal to 6. That means n square greater than is equal to 6n. So n greater than is equal to 6. That will be less than is equal to 3 into 2 to the power n plus 5n square. That will be less than is equal to 8 into 2 to the power n. So f of n is equal to big O of 2 to the power n. So we have proved that f of n is equal to omega of 2 to the power n. We have proved f of n big O of 2 to the power n. So that means we can easily say that actual value of f of n is equal to big theta of 2 to the power n. Because it satisfies both the upper bound as well as the lower bound. So for theta, both the condition has to be true. Go through it and tell me if any problems are there. Any problems are there?
Sir, in case of programming, when
Hmm.
how can we assume or how can we find this kind of omega or
We'll go for that.
theta?
We'll go for that. We'll go for
Okay, sir.
that.
Okay, sir.
We'll go for that. On the next session, I will show you how the complexity of for loop, how the complexity of if statement, how normal conditions are being calculated. We'll go for that. We'll analyze everything. Today itself, I will discuss this thing. No issues. So, any question, anyone?
No, sir.
So, you should practice these things. I will provide you in the group hundreds of solutions I had made already for the university questions. From university questions, actually, I will provide you these things.
Sir,
And in every question paper, you will find that one, the first question, huh?
sir, you can't be added to a group. Your privacy settings is
Yes,
not
yes, okay,
public.
just okay,
I
just
have
send the
sent you the
invite. I
invite.
will. Yes, yes,
Yes,
okay,
sir.
okay, I will
I have
join.
sent you
Okay,
the
I will join.
request.
I will join. I will join. Nice. Just a minute. I'm joining. So I have joined over there. Now the thing is that it, huge candidates are there. Around 30 candidates are there. So only this much has joined in the class. What's the situation? Whether all are not informed?
So the class schedule is always posted in the group whenever there is a class.
Then today we have one class and one more class. When? At 3 p.m.
Yes, sir.
Yes, sir.
3 to 4 p.m.
Yes. So try to be join in the class. Anyways, now let's start with another thing. 8 more minutes are there. So if you go through the question papers, you will find these things that around 10 marks or 15 marks will be there from this kind of calculating big O notation or big theta notation or big omega notation. Now analyzing algorithm control structures. The second one. What are the control structures we are encountering in our programming? Some of the algorithm control structures are sequencing statement, if then else statement, or for
Yes,
loop, while loop may be there, and recursion. Generally, these 5 types of control structures we are found, isn't it?
yes, sir.
Generally, these 5 types. Generally. Now, suppose our algorithm consists of 2 parts. One is A, another is B. A takes time TA to execute, and this is TB. So total time for computation will be TA plus TB, isn't it? The first one is sequencing. Say we have 2 statements. One will take TA time, another will TB time. So total time requirement is T or TA plus TB, isn't it?
Yes, sir.
Yes, sir.
But suppose in the CPU, A and B both comes at the same time, and A takes 5 minutes, B takes 2 minutes, suppose. So what will be the total time requirement?
5 minutes.
Yes, very nice. Max of TA and TB. This will be the time requirement for sequencing statement. Exactly. So like TA will take big of n and TB will take theta of n square. Suppose. So here computation time is equal to TA plus TB is equal to max of TA TB is equal to max of big of n theta of n square. Obviously the square value will take larger time, so theta of n square. In that way the sequencing statement, time requirement for sequencing statements will be calculated. So we shall start with the if-else statement on the next session, but before that, if you have any question regarding books, one more thing, have you got the study material?
Yes, sir, we have.
But along with that, if it's possible, just download the Rima Thareja's book. Sorry, not Rima Thareja. For algorithm, just download the Horwich Shahani's book. Horwich Shahani algorithm. This one is one very good book. So you can go for that one also. This will be very
Can you
helpful
write
to
the
you.
name?
Horwich Shahani, yes, I am just writing. Horwich Shahani. Horwitz Horwich Shahani. Shani. This one is good one.
Yes, sir. Okay.
So next session we'll start with that if-else statement. Along with that, remember one
Yes.
very important concept we are going to explain on next session. This will be the knapsack problem. And if you find your question almost in every year, this knapsack problem is there. We will solve it out. This is one very interesting problem. We will solve this one on next session. And please try to join before 10 minutes. I will open the classroom. No problem will be there to join.
Okay, sir.
So,
Yes, sir,
so
we'll
that
do.
we will not waste a second, because we
Okay.
have only 1 hour classes in. See here, up to 10:30, around 10:30, some people are trying to join. So I will not permit this thing. Whenever I am, my time will be there, I will join and I will leave the meeting, not in that way. This can't be done. So chalo, this much for the first session. We have already, it's around 11. So thank you. We shall meet on 3 p.m.
Okay. Thank you, sir.
Okay, sir.
Not,
Thank
no,
you.
2:50. We shall meet on 2:50 p.m. Remember.
Yes, sir.
Okay,
250.
sir. Thank you.
Okay, sir.
Yes, yes. Okay, chalo. Chalo, thank you.
Hello.
Yes.
Can anyone hear me?
Yes, we can.